On a Wednesday morning in October of 1995, a $500,000 crane fell over at a bridge construction site in Carroll County, Iowa. The massive machine, weighing 160 tons, sank into the mud and stopped a multi-million-dollar county project dead in its tracks. For 4 days, the smartest engineers with the most expensive degrees stood around holding clipboards, completely unable to figure out how to stand it back up. Every modern solution was either too expensive, too dangerous, or physically impossible. The project was facing absolute disaster and careers were on the line. And then on the fifth morning, an old farmer in muddy boots drove up to the site on a machine built before the stock market crash. He looked at the engineers, looked at the sunken crane, and told them he could fix their problem. And naturally, the experts laughed right in his face. Let me set the scene, because the setting matters just as much as the machines. The Middle Raccoon River crosses Carroll County in a long, lazy series of bends through flat farmland. In 1995, the county was replacing a two-lane bridge on a rural road. The contract went to a mid-sized firm, and the project manager was a man named Keith Scanlon. Keith was 45 years old, an ex-military man who ran his construction sites like a commanding officer runs a platoon. Everything was scheduled, everything was documented, and everything was done exactly by the book. He had a reputation for bringing projects in on time and under budget, which was exactly why he was put in charge of this bridge. He intended to have the project finished by Thanksgiving. Keith's key piece of equipment was a mobile crane manufactured in Germany that cost $500,000. It was a marvel of hydraulic precision that could lift 160 metric tons and extend its boom 200 feet into the air. It had more computing power in its control cab than early space flights. Keith loved that crane and trusted it completely. On October 11th, the crane was scheduled to set the third of 6 massive steel girders across the river. Each girder weighed 42 tons. The crane was positioned on the east bank on ground that the surveyors had officially certified as completely stable. The operator deployed the 4 hydraulic outriggers, locked them into place, checked his load charts, and began the lift. The girder rose off the flatbed truck, swung slowly over the river, and began its descent. But then the ground moved. The east bank, which had supported the crane perfectly for 3 days, suddenly gave way. The outrigger pad on the riverside, the one bearing the absolute most weight during the swing, punched through the surface crust and sank 18 inches into soft, hidden clay. The operator immediately dropped the massive steel girder into the river to save the machine, but it was too late. With one outrigger buried, the crane began a slow, sickening lean toward the water. The massive 8-ton counterweight designed to balance heavy loads was now working against the machine, pulling the back end up as the front end went down. The crane fell in slow motion, settling onto its side, with its boom resting in the shallow water and its outrigger buried 3 feet deep in the mud. Keith Scanlon stood on the bank and stared in absolute horror. His $500,000 machine was completely helpless. He immediately called for backup cranes, but the inspectors took one look at the soft ground and refused to bring heavy equipment near the bank. They told Keith it would take 5 weeks to stabilize the soil and bring in a larger crane. Keith's Thanksgiving deadline was ruined, and his career was on the verge of collapsing right into the mud. Let me tell you about Harlon Meyer, because understanding the man is the only way to understand what happened next. Harlon was 78 years old and had farmed 480 acres in Carroll County for 53 years. He took over the family farm back in 1942 and had seen heavy equipment evolve from horses to basic gas tractors and eventually to massive computerized machines. He farmed the land directly north of the construction site. For 4 straight days, he had been watching the bridge project disaster unfold from his kitchen window. He watched the crane go over, and he watched the experts stand around with their clipboards, completely paralyzed. On the morning of the 5th day, Harlon decided he had seen enough. He drove his everyday John Deere down to the site, parked at the fence line, and walked over to where Keith Scanlon and 2 engineers were staring helplessly at the mud. Harlon looked at the tip machine and calmly stated that he could right the crane. Keith barely glanced at him, taking in the faded overalls, the muddy boots, and the white hair under a worn-out seed company cap. Keith asked him how exactly he planned to do that. Harlon replied that he would use his crawler, a Caterpillar 60 built in 1928. Keith Scanlon started to laugh. It was not a polite chuckle, but a deep, mocking laugh that made his hard hat tip forward. The 2 highly educated engineers joined in, and a few construction workers resting by a trailer started snickering. Keith wiped his eyes and shifted his tone to the gentle condescension of a man explaining basic physics to a confused child. He pointed out that the ancient crawler weighed only 10 tons, while the modern crane weighed 160 tons. He slowly explained that a 10-ton antique cannot possibly lift something 16 times its own mass. Harlon did not flush with anger, and he did not raise his voice. He stood with the absolute patience of a man who had been underestimated his entire life. He calmly corrected the arrogant project manager, explaining that he was not going to lift the crane, he was going to tip it. He explained that because the crane was resting on its side, its center of gravity was already past the tipping point. All he needed to do was apply enough horizontal force to start the rotation, and gravity would finish the job. He detailed how the Caterpillar 60 produced 65 horsepower and ran through a specific 3-speed gearbox that could deliver 11 tons of relentless sustained pull in first gear. The engineers suddenly stopped laughing. Harlon then delivered the final undeniable lesson in mechanics. He pointed to the soft clay and explained the concept of ground pressure. He noted that the heavy modern crane concentrated 3,000 pounds per square foot onto its outrigger pads, which is exactly why it punched right through the crust and sank. His ancient Caterpillar distributed its 10 tons evenly across 40 square feet of steel tracks, resulting in only 500 pounds of pressure per square foot. He promised his machine would float on the soft mud while pulling the massive crane upright. One of the young engineers frantically punched the numbers into his calculator, looked up at his boss, and quietly admitted that the old farmer was absolutely right. Let me tell you about the Caterpillar, because she is the reason this story exists. The Caterpillar 60 was built in Peoria, Illinois in 1928, exactly 1 year before the stock market crash. It was the largest crawler tractor they made at the time, 10 tons of cast iron and forged steel, powered by a 4-cylinder gasoline engine that produced 65 horsepower. It rode on 2 massive steel tracks, each 12 feet long, studded with grouser bars designed to grip absolutely any surface. Harlon's grandfather had bought the machine new, and it had been working on the exact same farm for 67 years. Most people who saw the Caterpillar 60 thought it was a relic, something to photograph and forget. Harlon knew better. He knew what the machine could do because he had spent 53 years asking it to do things modern equipment could not. The Caterpillar 60 did not have a computer that limited its output. It did not have sensors that automatically cut power when the load exceeded a safety threshold. It did not protect itself from overexertion the way modern machines do. It just pulled. It pulled relentlessly until the job was done or something broke. And in 67 years, nothing had ever broken that Harlon could not fix in an afternoon. Harlon positioned the crawler about 150 feet from the tipped crane on the uphill side where the ground was solid. He killed the engine, climbed down, and began uncoiling a logging chain from the back of his machine. It was forged steel with links as thick as a man's thumb, rated for 30 tons. Harlon waded through the soft mud to the crane, carefully testing each step. He hooked the chain to the crane's main frame at a point he had calculated would produce the maximum rotational force. He did not attach it to the top or the boom, but to the frame about 2/3 of the way up from the ground. The young engineer with the calculator asked him why he chose that specific spot. Harlon explained his farmer mathematics without hesitation. He told them that if he hooked too high, he would be fighting the full weight, and if he hooked too low, he would not get enough rotation. That exact point gave him the perfect mechanical advantage. He explained that the crane inherently wanted to rotate around its grounded tracks, and he was simply helping it do what it already wanted to do. The modern engineers were trying to lift the immense weight, but Harlon was just trying to tip it. Harlon climbed onto the steel seat of the Caterpillar and engaged the clutch. Let me tell you about the next 4 minutes, because they are the reason every person at that construction site still talks about this day. The chain went taut, not with a sudden snap, but with a slow, steady tightening. The forged steel links straightened one by one as the tracks bit into the ground and began to pull. The grouser bars dug into the earth like teeth, finding solid ground beneath the soft surface. For 10 seconds, nothing visible happened. The chain was incredibly tight and the Caterpillar was pulling, but the massive crane was not moving. However, something was happening that the eyes could not see. The center of gravity was shifting infinitesimally. Harlon kept the throttle steady. He was not trying to jerk the crane over, because that would snap the chain. He was applying constant, patient, relentless force. At the 2-minute mark, the crane moved an inch. A sound like a deep groan came from the metal frame, stressed by forces it had not been designed to experience from this direction. Harlon pushed the throttle forward a fraction of an inch, and the engine note deepened. The tracks gripped harder, throwing small clouds of earth behind them. 5 degrees of rotation, then 10. The boom began to lift from the water, slowly rising like a mechanical arm reaching for the sky. Keith Scanlon stood completely still. He was no longer laughing. At 15 degrees of rotation, the massive 8-ton counterweight began to work in Harlon's favor, pulling the machine back toward upright. Harlon could feel the exact moment when the crane's own weight began to do the work. The resistance on the logging chain eased and the engine note lightened. The crane was past its balance point and completely committed to falling back the other way. Harlon eased the throttle back and watched it go. The crane fell back onto its tracks with a shuddering impact that shook the ground and sent a massive wave of mud across the riverbank. It rocked once forward, then back, and finally settled perfectly upright. There was absolute silence on the bank. 25 construction workers, 2 engineers, 1 project manager, and 1 old farmer stared at a $500,000 crane that was standing upright and absolutely should not have been. Then the cheering started hitting like a massive wave. Men were shouting, whistling, and hugging each other in total disbelief. Keith Scanlon did not cheer. He walked deliberately through the mud to where Harlon sat on the idling Caterpillar. He looked up at the old farmer and asked how much he owed him for saving his career, and a $20 million bridge project. Harlon calmly asked for a donation to the Carroll County Historical Society. Keith nodded and later wrote a check for $15,000, which was $5,000 more than Harlon even asked for. Before leaving, Keith asked how Harlon had solved the problem in 4 minutes that his highly educated engineers could not solve in 5 days. Harlan shut down the engine, creating a sudden dramatic silence. He climbed down from his ancient machine and delivered the ultimate lesson. He explained that the modern engineers had been trying to lift the massive weight, but he was simply trying to tip it. He patted the steel tracks and told Keith that modern machines are incredibly smart because they calculate loads and protect themselves from damage. When things get difficult, a smart machine will completely cut power and refuse to work. But his ancient crawler was completely dumb. It did not know its own limits. It just pulled relentlessly until the operator told it to stop or until something broke. Harlan looked right at the arrogant project manager and told him that sometimes when you are facing an impossible problem, a smart machine will simply refuse to let you fix it. But his dumb machine always would.
Let me ask you something, and take your time with this one. Where exactly is the true limit of a machine? Modern engineers design brilliant equipment with dozens of sensors and massive computing power. They calculate loads and automatically cut the power to protect the machine from destroying itself when things get difficult. That is excellent engineering for a normal day. But when you find yourself in a situation that is absolutely not normal, when you need to push past the boundaries of what a computer considers safe, a smart machine will simply refuse to let you do it. The 1928 Caterpillar was completely dumb. It did not know its own limits and it did not know when to quit. Its only safety system was the brain and the experience of the man sitting on the steel seat. Never confuse modern technology with actual problem solving ability. Machines might get newer and more expensive, but the man operating them always has to be smarter than the machine. Now, before we finish, I want to share a small secret with you. While the careful genius and the stubborn spirit of this tale beat in the heart of every rural American town, the specific names and events like Harlan and his perfectly maintained antique crawler are a carefully crafted legend. It is a fictional tribute dedicated to the countless quiet farmers across this country who understand that old iron still has a place in a modern world. If you believe in the undeniable genius of the American farmer and the absolute value of old iron, please hit that like button and subscribe to The Farm Legacy. Go down to the comments right now and tell me if you have ever used an old piece of equipment to solve a problem that modern technology could not fix. Until next time, always remember that sometimes the best way to move forward is to rely on something built a long time ago.